10 years. I don't know, about 2,000 students.
So we're not going to challenge it, that's all right. No one's going to say you're off by 20 students, Becky.
You think so? That's at the college level, because I taught elementary and junior high before coming here.
Do you want to add those in?
I gotta do some more math. Maybe about 3,000.
Maybe another 1,000?
Yeah.
Why not?
I'm Kathy Hooper, and I'm from Illinois. I teach at Principia College. I've been teaching probably for about 4 years, so I guess around 300.
300, okay. So you know all the names of those 300. Just wait and look some number like that.
I'm Betty Paternoster from New York City. I teach at one of the colleges of St. John's University, and been teaching most years since 1961. I would estimate about 9,000 students.
I'm Frank Hickman from Niagara University. I've been teaching 40 years. 9,000 students. I can't. 8,000 students.
Okay. Nasser Hassan from University of Estonia, Cairo. Previously, I taught in Iran, originally from Iran, but I'm a US citizen. About 20 years of teaching, I go around 4,000.
4,000 students? All right.
Robert Dawson, St. Mary's University in Halifax, Nova Scotia. I've been teaching for 7 years now, and I suppose over 1,000 students.
Kim Martello from here at Monroe Community College. I've been teaching for 7 years, and I've got 1,000 students.
My name is Tom Danlin. I'm also from Monroe Community College and was born and raised here in Rochester. I've taught, I guess, about 5 years, and I think I get about 500 students.
I'm Jack Stanton of Monroe Community College. I just got my 30-year watch. I've taught over 7,000 students.
Sue Goodrich from Herkimer County Community College. I've been there for 20 years, teaching everything from chemistry, biology, right up through now mathematics and statistics. And not accounting for repeats, I think it's probably about 6,000.
Glenn Gabansky, I'm the high school teacher. I teach at the Oak Park and River Forest High School, which is in a suburb of Chicago. Between the 2 years in the Peace Corps I taught and then the years there, it's about 25 years now, I'd say roughly 4,000 students. I'm just curious, not being a college teacher, I see usually the same students for the whole year. I wonder if you people see them a semester and then a whole new group. So,
by some factor.
Let's talk about classroom minutes now. Classroom student minutes.
Okay.
David Mathiasen, I teach at RIT, which is down the street. I guess it dates me, but I'll just say 5,000 students. 5,000. I feel younger if I said 1.
Right.
I'm Terry Gothier. I teach at Finger Lakes Community College just down the road. I live here in Rochester, and I would estimate about 1,500.
Nancy Boynton, I teach at SUNY Fredonia, and I've been teaching for 19 years, so about 4,500. And one of them was Terry.
All right. Here we go. We started teaching the same year. 1961 was my first year of teaching, not here. And so that's 36 years.
But I started in high school.
So did I. That's right.
And in our high schools, we did have semi-annual promotions. That's why my number's very high.
So your numbers. I figured, though, altogether 9,000 was the homework I did ahead of time. So that was, and that's the number you gave, isn't it? Wasn't it?
Yes.
9,000. Okay. How many is that? Whoa. What do you got? 11,570 plus. 23 plus 10, 20. 22 equals 55, 60. Oh my gosh, I forgot myself. What's that? 6, 15. 60, 71, 72,000? 70,000?
No, 72,000.
Oh, 72,000. 70. 72,070. As a small group, we have influenced in some way or other 72,000 people. Well, that says to me that we're in the right spot. I'm in the right spot at the right moment, because this is a time of sharing. You've listened a lot to other people, and now we get a chance to talk with each other. And for people who have come in contact with 72,000, I've got to believe we've got some stories to tell, some ideas to share, some questions to ask, some things we're still wrestling with. I don't know if you've answered all the questions about teaching, but I keep finding that there are more questions that I want to get in touch with, especially about teaching statistics. One of the things I'd like to share to begin with is that I've been reading this little book called Creating the Teachable Moment by Darlene L. Stewart. She was an elementary school teacher at first and got a bit frustrated with the difficulty she had in teaching students. So she studied psychology and became a counselor, and then continued to do some work teaching small, younger children. And teaching a lot of reading is one of her main areas. But I find, I'm sure that a lot of the things that she goes through and talks about and the ideas she comes up with are going to be common to my teaching of college students. There are some things that I think really do go together. I don't know about yourselves. I know we're not all statistics teachers here, because I know Jack comes out of the biology department, but he's a lover of statistics, or at least a user of them. And, but I tend to think in a kind of a linear, organized fashion. I think that's the way I present probably most to my students. Here's the simple concepts, and then that leads to a little more complicated. Don't you see the logic in that as we're progressing? She suggests that students don't always learn that way. That instead, sometimes they take that magical step from concept to understanding. And she talks a lot here about insight and how students and we, in fact, learn a lot of things by grabbing on, and somehow comes out to be insight. And she says that, she suggests that when we demand too little of our students and don't challenge them enough, they become bored. And I think we've experienced that. When we demand too much for their abilities, they get frustrated and confused. And in between boredom and frustration or anxiety is insight. She suggests how we might prepare the way for insight. First, to create that mood of learning. And I think that's what we need to do as individuals. And we work at that a lot, I'm sure. Second step is to provide a variety of interesting, relevant input for the students. And third is to allow time for incubation. I planted some seeds in my flower garden 2 days ago. They got rained on last night for sure, but they're not up yet, right? I've got to wait. I've got to wait for those seeds to grow. Now, what I understand we're about this morning in this session is step number 2, providing a variety of interesting, relevant input. At least that's what we're going to be talking about. And we've had some ideas about perhaps how we can bring the real world into our classroom through our 3 presenters, and perhaps even from some conversations as we've talked about. So that's what I hope we can share this morning. Just to to start off a little bit, one of the things I do sometimes is borrow, let me say first, we're talking about having labs with statistics. If I could have a lab with my statistics courses, it would be filled with measuring instruments, scales, something to measure distances, stopwatches, perhaps titration to measure concentrations, to measure a variety. I want students to know that this is not that this X bar, this average they calculate, is not the average of these numbers. It's the average weight, or salary, or distance. There are units, for the most part, of all of those measurements. And I think they need to know that. Because for me, they need to know that statistics comes from the world. So I like to do that. And what is a major part of statistics, I think, is variability, right? Without variability, where would we be? So where does variability exist?
I think they just understand it. Because they have learned mathematics, and then everything is sure. And then
Yes.
and statistics, and suddenly there's variety.
Suddenly there is variety. And variety exists everywhere. Yesterday we measured peanuts. I've got a bowl of peanuts over there, and second section we measured apples. And we know those are different, don't we? But pieces of chalk were all made to be the same. Do they weigh the same? What would you guess? This scale, and you folks, I'm sorry, you can't see it, measures to the nearest tenth of a gram. That's 10.07 grams. And this one, students, is 10.10 grams. These things which were made...
First one back up there.
You think I didn't let it settle in?
No, but this source of variation.
Another source of variation is not just the chalk, but
Like scale.
scale or meat.
What scale is that?
And so, 10.09, 10.10. So that, in fact, variability exists all over. And a lot of what we want to do is measure it, analyze it, and eventually perhaps control it in some fashion. So when we get data, I try to make it real data. How do you get data? What do you use for data in your... Do you measure things? Do you use numbers out of textbooks? What's effective here?
What I find is that I teach stats to graduate students doing their master's and PhD.
Okay.
And many of my students would have had previous stats courses, but they're very theoretical, and they still have this great phobia for stats. And at the master's and PhD level, they're going to be writing their thesis or dissertations. What I do is, for each concept or principle I teach, I have a background in epidemiology, that's health-related research in high-risk sexual behaviors for HIV. And I find they're very receptive to things on sex, sexual behavior. They listen.
Who discovered that?
Each concept or principle that I teach theoretically, I find a study, and there are many studies, that utilizes that concept, something that they're in touch with, so they know this is real. And it gets the message across.
Grabs their attention.
Yeah, and they see, okay, if I teach standard deviation, if I teach regression analysis, it's utilized here. And because they like this topic, they look for the findings, they follow through. And I find very often that they get the concept, they can apply it.
And when the findings are out, they're more than just mathematical results, are they not?
Absolutely how it should be, you know. I mean, many of them go into these classes in very rich background in statistics, but not applied. Mathematical statistics. They know the theories, they know the models, but they're unable to apply them. So I've found that teaching statistics with a research design framework, because ultimately that's what you're going to use stats for.
Okay, it's a tool.
Yes, that's the only use of stats. You know, so that's why I like conferences like these, because they add to the mathematician the research framework, which is lacking sadly in many teachers and professors. You know, if you have that research framework, you know what to throw out, you know what to de-emphasize, where to place more emphasis, you know, and it's more operational, it's more practical, it's more applied, it's more real life. And as you go higher, that's objective of teaching.
Okay.
Yeah.
I think scores on examinations and tests are very important to students these days, because number one goal of the students to have a good grade, as we all know. So actually after the exams, or even not the statistic class talking about average, students don't know anything about standard deviations or variance, or even the interval of A or B or C and so forth. So we can go to even a histogram of these things. And I tested, it seems students were looking at me differently than the other days, and say, well, these are the scores, and of course not giving the names, be confidential, but then both sides, A students or F students, D and B and so forth. So we can talk about normality or not being normal or flat, or so they get lots of good ideas of the statistics.
Because they're pretty close to those numbers, aren't they? They're pretty close to those measurements.
Yes.
That's good. Other ideas about where we get data? How do we, yes, right.
There are a certain number of things that are always available in class. I mean, everybody has a height, although there was one instructor at our university who decided on the spur of the moment not to use that because there was a student in a wheelchair in the class. I'm not sure whether that was a good decision or not, but I mean, it wasn't that he mentioned he was going to do it and then scrubbed it because of that. He just didn't mention the idea and moved on to something else. Another thing that is always available, everybody has a few coins on them. Every coin was made in a certain year, and you can, I mean, if nothing else, if you do a histogram of the years in which the coins currently in the classroom were made, you get a distribution which will be different than most other ones. If you do it by year rather than age, it's actually skewed to the left rather than to the right, which is something that students get told about perhaps, but see fairly rarely.
Those are numbers they produce themselves. The test scores. Is it convincing to pull numbers out of other places? I happened to go through the local paper here, Democrat and Chronicle, and got about a dozen places I could look for. I've got temperatures. There's a police blotter in here which lists ages of perpetrators. Is that the right word? There's the obituary column, and doesn't list everyone's age, but it lists a number of ages. There's the stock exchange. There's always a list of local stocks, and you've got a bunch of numbers there, don't you? There's the film. Even the films. And do you know what numbers I got out of there? The listing of films. The length, yeah. The films that tells you how long each of the movies are. Now, much less we go to the sports pages, and there you can't stop, but there are golf scores in there. They've got the LPGA from the last tournament it was, and not the present one. There's the baseball report. Have to be a little careful that not everybody's a sports fan in a class, so they don't all like all of the projects that I might like, but length of games, attendance at games are in there for baseball, for instance. Those are not strictly related to too much. Classified ads, prices of cars, prices of homes, prices of apartments. There's a real estate transactions listing, which is, it lists the amount of the transactions reported to the various towns around, and when can be a little careful there. You get a number of prices in the thousands, hundreds of thousands of dollars, and there's one there that says $7,000. It looks a lot like an outlier, but it probably is just some land it's changing, or because of the real estate, I don't know what else is figured in there, but this is the amount recorded. It is not necessarily the price that the building went for. Are these convincing to students, or do we need to generate the data themselves? What do you like to do? Yes.
I think it can go both ways. Now, I've only done this 1 year, but at the very beginning, we do a little class survey. There's a bunch of questions, real standard things, age, height, weight, perhaps shoe size, and the kids can suggest some other things. But we collect data about the students themselves in the class, and then I'll use that over the next few weeks. I might do a box plot or a histogram or a dot plot and scatter all sorts of things about this, just to show them examples of data that they ought to have a bit more interest in, because it's about themselves. Number of shoes you own, how much you paid for your last haircut. These things give nice sex differences that are kind of just interesting. Another thing, I'm going to be using Rossman's textbook next year, and whenever you're dealing with data, he uses real data, and he documents where he gets the data in the back of the book, but it's all real data, and a lot of the things, I think, are things that the kids have some interest in. So, but are they really excited about this stuff? Hard to say. I think there's more of a chance if it's either data about themselves or data about, realistic things that they might have some interest in, rather than some just abstract collection of numbers.
I do something like that with a survey also of the shoe size and all those things, and then one of them down toward the bottom is the arm span. And they're like, well, what do we do? And then they'll say, oh, it's the same as my height. And I go, well, can you be sure? And they say, well, how are we going to do this? So I have tape measures in my book bag, and take it out. And then they find out that, they're measuring somebody. Do we do the front or the back? And then they're saying, hey, wait, you got to keep your fingers out. We got to be consistent. And that came up, which was kind of interesting. That we got to do everybody the same way. And so we had, it kind of went a little more than just things they know. We had to do the actual measurements, and they saw they had to be consistent. And then I do that for about 4, I say 2 of mine and 2 about Johnson's. We put it together, and then we have a much bigger sample size to work with.
Now, Pat's worried about, I don't know, she didn't say she was worried, but she's interested or curious in that everyone was done the same way, so that the collection of that data. I gather she doesn't just want to get a bunch of numbers to work with. How fussy do I have to be about it? I mean, suppose I said, this is a first statistics course. Let's not burden my students with all of the niceties of random sampling to the nth degree and measurement exact and perhaps definition of it. Let's get them a working knowledge of the language of statistics. Let's get them a working knowledge of the viewpoint of statistics, the kind of problems that can be solved, a little bit of the probability background. And let's not bog them down in all of this. You can see, as we've heard these presented, all in the real world, it's tough. There's one of our fellows here teaches adjunct for us, and works as a statistician, says, in the real world, there's no clean data. It's all 30 to something. Now, if that's my point of view, and am I doing a disservice to those students as they go on? Is that really?
Students insist on it.
What do you mean?
That the students at this level tend to be extremely perfectionist about the little details of measurement. Even if they don't know quite what to do with the data once they've got it, they can be real type J personalities about making everyone do exactly the same thing. And
sticklers. Okay. So
I would say that's good. Let them do it how they want to do it. Then you present the data. You say, okay, let's do a critical analysis of these data. What are the problems? How much confidence can we have in this? And now you say, okay, you did not all measure the same way. So, stick a pin. We can't do this. it can reinforce something and get the concept across that you should do it differently or standardize whatever we do.
Yeah, I think you at least need to plant the seed of distrust of statistical results and let them gather data, you know, as quickly as they can to work on a project. But then, like you were saying, talk about what kinds of things could have gone wrong afterwards so that students can ask those critical questions, which may turn out to be the most important thing in the long run. They may forget the procedure, but they can ask, I wonder how that data was collected. Was it collected consistently? And those are the things that can make results that students may encounter believable or not. Those are the things that turn out in the long run to be just as important as the basic concepts.
Those issues of how do you write questions for a survey come up immediately when you let the kids make up questions, because invariably somebody's going to say, have you done drugs? And immediately you're off onto a conversation. Well, what do you mean by a drug? Do we include cigarettes? Alcohol? And then you can spend an hour in class discussing this thing, and it's a little bit frustrating, I think, in some sense, because you probably can't come up with a question that satisfies everybody. But they want to include something like that in there. But it's very difficult. They learn right away that it's very difficult. You have to. I try to get them to see, you have to ask yourself first, what is it you want to know, and then talk about framing your question, because every person comes up with a question, a different variation of it, and it's got all slight, subtle, different interpretations. And I think that idea just comes naturally, it happens automatically, and I think it's good to see it happening right at the beginning. But I don't think, I've never been able to, since I'm kind of new with this, feel like I've really been able to do a good job at coming up with questions like that. Those kinds of questions just are never easy to, to ask easily, ask clearly.
I know David teaches some students further along the line of statistics. Jack's in the field of science biology. Does this my attitude disturb you at all? Okay.
Well, I was thinking as the conversation going on, I was listening that one resource you folks could use would be genetic corn. Have you ever used genetic corn? Because there are several traits that follow very precise ratios, and of course the samples are easy because you have a corn cob in front of you, and you can easily identify the traits you're working with, and you can form a hypothesis and test the hypothesis, use chi-square or whatever. So it provides a neat way to do the sample. It prevents some problems of how many rows do I count, and then sometimes there's a little color variation in the corn. How do I interpret this? Because is this purple or is this white or is it yellow? And all these questions come up. Is the seed wrinkled or round? And the corn is provided in several different varieties, so you can pick several variables. And there's a lot of stuff, a lot of mileage and statistics people could get out of that. Now, we're limited somewhat because in the course I teach, there's no mathematics requirement. So I have to develop a lot of very fundamental things. You can't take it very far. But boy, in the statistics course, you can do a lot with that.
David, did you want to react?
Well, I just felt like you were baiting us.
You saw through my...
I mean, whether you're measuring chalk or having the students fill out surveys, getting the students to buy into something so they have some ownership is how you get something through. Bob Johnson was always a big proponent of these projects. And every student goes off and does their own project. And then, of course, the teacher has to grade 1,000 of them. But
right.
These issues of sampling and consistency are immediately there when the students are doing something themselves, so you can't avoid them, but getting the students to own the data, in whether you provide it and they understand it or they collected it, that way they pay attention and they do something.
I like the way you put that, getting to own the data. Yeah.
I've had my students collect their own data, and given the fact that they get messy data or bad data or it isn't a random sample, I think they learn much more about random sampling by getting a bad sample, or they understand more about sampling in general than even if I just throw data at them. I think it's better. My opinion is, as much as time will allow, get them out there, get them asking their own questions, collecting their own data. I would agree.
Yeah. And there are some concepts in statistics and probability which is very difficult, but if we do it in practice in class it would be easy, like conditional probability or joint probability. I divide my student in the class group of male and female students, so that's a partition of the set. And also I say, well, like I teach in Iowa, say from Iowa, not from Iowa, freshman, not freshman, and then in ordinary language I probably say given such and such, well, these are the group of female students in the class, how many are freshmen? Then the students counted and then actually write the table on the board, different tables. And it's just not embarrassing, nothing to even measure, I mean just counting. And I have found that they learn that pretty easily and they enjoy because physically they walk around the room and divide themselves in corners and say, well, these are freshmen, these are non-freshmen, and they know each other, and I say, talk to each other, and so forth. It's going to work for me.
I used I think a similar kind of thing. For me, I always wonder how much probability to do. You know, probability is, you use it so much to talk about it, but that you can get bogged down in probability. And a class I had, I think it was, tried at the table, and this was males and females, and did you drive your own car to school or not? So they drove, and they
Didn't have to.
did not drive. And we did the sample, you know, and I don't remember the numbers, but we showed using the adjective before that these were not independent. But it doesn't matter, they said, whether you were male or female, or whether you drove your own car. So the data says something else. Now, of course, this was a small sample, and we weren't up to levels of significance at this point. But you know, the same kind of thing. It was from them, and from that discussion. Wow, it was not easy though to explain why the data showed some kind of relationship existed. For whatever reason. And then we started to, you know, speculate on what the reasons might be, which was, for me, exciting because they were looking behind the data and studying relationships, and that's what, for me, a lot of statistics is, the relationships. Now, but the other thing I do, and maybe you do also, involve more game kind of things, like you have a I brought two. Oh, they're all right. Some of which are rotten, and if I decide to make an omelet and take a couple of these randomly, what is the probability that I will get 2 eggs that are rotten, or 2 that are good, or 1 of each? Trying, I guess, to show, again, in some fashion, independence or sampling without replacement. You know, I sometimes don't tell them whether it's good replacement or not. They say, well, you're going to replace her? I said, look, I'm making an omelet. Now, you think about it. Am I replacing her or not? But it's a game. Do you use game kind of things? Is that effective? Am I out of play? Should I look for more serious approaches like we're doing? What's your balance? Your balance? What's your sense here? Games by everything. Do everything? Whatever works? Yeah. Games work?
Yes.
How often do you get to use games?
I worry because for probability I worry because I don't want probability just to be coins and dice and cards and eggs. I want it to be real. And I think it's not, I mean, in some sense we could perhaps think of a lecture about all the places we use probability, or it faces us, or we face it during the period of one day. Now, which way do I go home to get there the fastest? I have 3 different routes I can go to my house. Chances are I look at the time of day and decide in some subtle, unconscious way, probably which is the fastest way, right, Jack?
Yeah, well, another one is the physiology class. We do things students are interested in. For example, we have them, those who smoke, go outside the building and puff on a cigarette. Of course, take their blood pressure first, we have them come back in, take the blood pressure again. And you could do those kinds of things, or you could even set up a stepping.
High school.
Other than the cigarette, you could have them use one of these step devices and step up, step down. And blood pressure is not hard to take. You could show, within.
Wouldn't pulse rate work also?
Pulse would work also, and they're really interested in the cigarette though, because they're amazed at what happened.
You have to be careful these days where you send them, Jack. Our campus is becoming smoke-free. 50 people in the building, you're not invited to the intakes, right? Okay. So games are okay.
It's very easy to do a Monty Hall experiment just using 3 file folders and photographs inside. And this one's sufficiently paradoxical that it keeps people interested, and you can try it out several times to show that it really is better to switch to the stick.
Ah, well, that's the old classic kind of problem. That's a very quick summary entry to it, but I'd have to be reminded of what was the.
Okay,
what
so
is
you
the
have
question?
you're given a choice between, well, in the demonstration version, 3 closed file folders, 2 of which contain are empty, and 1 of which contains a picture of a car. And the idea is to find the one with the picture of the car. And however, it's not just a simple choice. First, you choose one of the 3. At this point, I open an empty one that you did not pick to show that it's empty, and offer you the choice of switching. Now the question is, should you switch? Should you stick? Does it matter? The usual argument is that it doesn't matter. The truth is,
it's 50-50. I mean, obviously, right?
The truth is that you improve your odds significantly by switching. Now,
it's obvious, right?
Well,
do we work out? I know.
You can work it out. I mean, you can work it out just by calculation. But I mean, the intuitive argument is that when you picked, you had 1 chance in 3 of getting it right, and clearly, if there's 1 chance in 3 that it's in the one you originally picked, and there's one other one it might be, and there must be 2 chances in 3 that it's in that one. But it does take a little careful argument to get the right answer. But I mean, one can test it out by having one person try 10 times sticking, 1 person try 10 times switching, and the experiment bears out.
So test that.
Yeah.
That's the thing about probability, of course. You don't have to do an experiment to calculate the probabilities. I mean, you calculate them without the experiment, and it's perhaps verifying them.
Yeah.
And how far you go, how many, if you were wondering what's the probability of 2 people having the same birthday, do you try it in your class? If it's, well, you probably do if it's, 24 or more, and you probably don't if it's less than 24.
So if it's less than 24, you ask people to include their mother's birthday as well.
Ah, and the probability goes to?
Well, at which point, if you have 12 people, then you haven't big enough sample.
For 24, very good. Yes?
I was going to say, because probability is so counterintuitive, and at least at the high school level, the kids are really weak in it. I mean, they can do real simple things. You got 5 blue chips and 7 red chips, and you pick out one, what's the probability it's red. They have no trouble with that, but anything beyond that really gets difficult. And so I think anytime you can concretely model what you can theoretically show them, the concrete stuff is going to help them understand.
Better than the numbers on the board.
Yeah, the numbers on the board are just purely numbers on the board for most of the kids. Although a lot of times when you want to do one of those things that is counterintuitive, the kids sort of figure, okay, it must not be the obvious, it's got to be the other thing, because why would the teacher be doing it? You know? So sometimes it's hard to sucker them into the sort of obvious thing, which turns out to be wrong because they figure there must be a catch. But it's still, I think, worth doing.
Yes.
Sport examples are very good for students. When there is a home game and they are anxious to see if their team is going to win or lose, the opponent, there are lots of statistics that we can, the students gather and say how many passes like in football, the quarterback threw and how many was intercepted or so forth. I think they go after it and collect this and they learn a lot. And then we ask them, what's the chance that your team win? That's objective probability. And so they get a good sense of these numbers rather than actually going to the text and saying it is all wrong.
I've used the football in the fall. Have one person, the guy that's running the game, and then we play it through the fall, and have people pick out for the 4 winning teams, the 4, in a 5, 6, 7, 8, 9, 10, and then when we get far enough in, we show very quickly that the best place to be is the bank.
Very practical you are.
We've done that. I've done that. Each week, Monday, day, and the first day of the class, we just have everybody do the pool. On the next Monday, we talk about the results.
What do we do for inference? Do you have ways? Cheryl and I talked about confidence intervals. How do you? I've got a class in 2 weeks. I want to try something with them. I'm going to try to explain what confidence intervals are. Somebody explained to me they were like horseshoes. Is that out? So I made these a couple of nights ago. I've got a 90% one and a 95% one and a 99% one, and I'm going to throw these horseshoes and try to hit the posts. But I don't really know where the post is, do I? And that's part of, I think what I'm going to try to show is that it goes and the post is in there someplace. It's not in the middle, as so many of the students will feel. X bar is in the middle, but mu is not. And at least the probability is very small that it's not in the middle. Will that work, do you think? I wanted a sort of an invisible post, if I could have it, some sort of image, that was there, that it wasn't, or maybe a smoke machine that, so we could. Yes?
But I don't know if there is a connection with the confidence interval. Yeah, they see that it's not in the middle, of course. I used a case of a hairstylist which claimed that 82% of his clients gained hair again. I don't know how you but it was only in the newspaper, it wasn't advertising. 82 people out of 100, and then I asked the student, what does it mean? Are you sure? Was it a sample of 100 people exactly? And discussed about that. And then I came to the confidence interval.
And you were able to separate the thinking from that sample or extend it from the sample to the whole population, you think?
That's difficult.
That's the trick, isn't it, I think? I like to ask students to write conclusions about their confidence intervals too. I've been doing that more and more. I won't accept, and I notice, I don't know the books, I don't find the books have gone quite that far always yet. It used to be someone would just put 2 numbers down. And that was about the worst way I thought we could see it. I insisted that they put at least a parameter down there. Mu ought to be there. In between 2 numbers, always at a particular level of confidence. But now I've gone to, I would need a sentence taken from the context of the problem that explains the meaning of that. So if they say, well, this means that if it's a percent, 82% of those people, or the 100 people, no, wait a minute, we're not talking about the sample. It's of all of the people she treats, 82% of those. Or between 75% and 90% of those people will actually grow.
The newspapers don't give often that information. They give a point estimate.
That's true, although I see more and more, they're adding the error of estimate in there. Do you know, this is, I look at the way they explain it, 95 times out. I wonder what people think when they read it. 95 times out of 100, this estimate will be within 4 percentage points of it. And I'm thinking, my wife is reading this, she's a nurse, does she really understand it?
But often people think when they calculate the confidence interval, they are sure.
Yes.
That's what they want to.
That's it.
Everybody wants to be sure, maybe psychological fact, but they think the parameter will be in it.
Mm-hmm.
And when you tell them 5% of the cases will be not in the interval, I think it's just worthless.
Yes, yes. What good is it? What good is it? Right.
What's the meaning of this?
Yeah.
The AP syllabus really emphasizes writing, and at first the kids were just kind of memorizing what I call statistical boilerplate stuff, my results are significant at the 5% level, things like that. And so I got the idea of something like what ifs, okay, your job is to report these results to a newspaper reporter who doesn't understand statistics, or write a paragraph that describes this, not using the technical language statistics, You're trying to convince your boss who doesn't understand statistics. You've got to find ways to explain these things using layman's language. And I think that helps. But they're not very good at it. I mean, they really have to practice at it.
It is how do we get them to write?
I find teaching inference, teaching the theory of context into one of the easiest ones, because nobody likes information from other people to be used to describe them. So you take a class and you ask, well, we all have breakfast, and then you say, okay, on Wednesdays, everybody here would have this or that. Somebody's going to object. Somebody, that's it. You say, that's it. I cannot use information from 5 persons to speak about the population with 100% confidence. So, since I didn't get all of you, I cannot be 100% certain. How certain can I be? And we go from there.
Yeah.
I have a question. Your group, it says beyond the formula, after we explain and practice and so forth, are we going to use the formula in statistics or not? Or how many of those?
That's David Moore starting to address that question.
I'm not saying memorize, but having in front of us still score point. Try it, I don't know.
Jack's got to do it in biology without any math preparation, so formulas are probably not the strong point.
I just going to mention something. There was a major thing reported in a journal about mitochondrial DNA. The DNA is passed only from you always get it from your mother for biological reasons, but a major anthropological report was made, and it turned out that the graduate assistant who was using the statistics package didn't understand the defaults in the program. And this was published in Nature, it was published in major magazines, and it's totally in error. So there's terrible dangers for people like myself. If I used the formula, I would check it out with somebody who understood it. Hopefully. Am I dealing in the right topic?
Well,
in the right area here? I think there's dangers to the formula if people don't understand it. Just an aside, I was fortunate enough I was in engineering, chemical engineering before I went into biology. I was fortunate enough to be in engineering school when you had to use a slide rule. Slide rule was significant digits were, and I learned where to put the decimal point. I learned something about logs and all that. That was really neat, but my students today have calculators, and they believe everything the calculator tells them, and they don't understand it. To me, that's the danger of the formula effect. Am I on the topic here?
Yes.
Oh, I think so, yeah.
I think after 1 or 2 years they forget it.
Yes.
They have to keep that intuitive notion of the concept. I think that's what you have to do first. Give them intuition, and after the intuition stays the whole life. They remember the concept intuitively and the formula. When we work ourselves, not a few years with some formula, we have to look it up again. So, but I think some students are interested in the maths behind this, and you don't want to disappoint them either.
Yes, that's a sort of, yes, and that's a stretch for us to do. See, our hostess has stood up, and I think that's a only way she could get my attention. I think I missed some of her other secrets. I thank you very much for your sharing. I hope we can take some ideas away from here, and if we haven't got all the answers, at least we've got some things to think about. And now, Kim?
And now, there are refreshments available in the 11306 upstairs, and we also have open computer labs that start in just a couple minutes, and those are in 206, 109, and 104. And if you have not had an opportunity to use maybe jump in, I noticed that it was not in 104, because I was in there yesterday. So you might want to go to 206 or to 109. But all of the software, is available. So please practice some more, and then we'll have lunch at 12 o'clock.
Okay, good. Thank you.
Thank you.